asymptotes or oblique asymptotes. So one thing we need to review is that a horizontal, Bennett, you want to put that away, and vertical asymptote, horizontal and slant asymptote, we can cross those asymptotes. Okay, it's just, we're looking at just as we approach positive or negative infinity. Then we're going to approach some, in this case, some line. Okay, some line. So a slant asymptote, we'll call them SAs, are diagonal asymptotes, or they're also called oblique asymptotes, common name. Oblique. They occur in rational functions when the degree of the numerator is 1 more than the degree of the denominator. Okay.
How do you write the domain of a slant? So everything is
It's still domain would be XER, except for it can't be, in this case it has a vertical asymptote as well, which it will. So negative infinity to 0 to 0.
It can be everything, but it can't.
No, domain is just the location of the graph. It never tells you what it looks like.
No,
right? So it's still going to go forever this way.
No, it is X.
Other than can't be your vertical asymptote.
Like whenever else was that an asymptote?
Okay, so a slant asymptote, a domain's not going to tell you if you have a slant asymptote. The functions will tell you that. Okay? All right, so how are we going to prove what the slant asymptote is? Well, we're going to rewrite this. So notice how the degree on top is 1 more than the degree on the bottom. Yes.
Is this slasymptote?
Slasymptote? Yes. Yes. Unless it was a situation where you can't have an x value that would make the denominator 0, like x squared plus 1 on the bottom. Right? No value of x would make that 0. Right. But as long, sorry, pretty much always. Okay, sorry. Correction. I would say 90% of the time. Okay, because usually we don't have a situation like that. Okay, so let's look at this function. We're going to divide. Okay, I'm going to start moving people, okay? So we can get through this lesson. We're going to divide everybody by x. Why are we going to do that? Well, we're going to use our limits. Okay, so as x approaches positive and negative infinity, what will this guy approach? 0, right? 4 over a very large number becomes 0. And so our function is going to approach y equals 2x plus 3. Thus, the function approaches the line. Okay, so it's really easy to actually get what the equation will approach because we can just use long division. And long division is so much fun. Have you done long division with polynomials? Yeah. Or waste time. Yeah? Okay.
So much faster.
Going up? So that would be my asymptote. Yeah. Okay, so procedure. We are going to check that it's a rational function. So check f of x. You should not skip words. Is a rational function. And it's a rational function where the degree on top is equal to 1 more than the degree on the bottom. So equals the degree of the bottom plus 1. Yeah. It's 1 more on the top than the bottom. So we're going to rewrite. I'm going to use long division. So we're going to rewrite this. So where q of x is our equal to mx plus b, and it's the quotient. R of x is our good old remainder. d of x is your divisor. So as x approaches infinity, we'll always have a situation where we're going to have the degree on the bottom here, the divisor is greater than the remainder, and so this will always approach 0. And so we're left with the mx plus b. So it's actually pretty simple. Let's go do some long division. Okay, so when we rewrite it in this form, like we did here, okay, so this is q of x plus this is our quotient over, sorry, remainder over our divisor. We divided everybody by x. It's a remainder of 4. Okay, so this will approach 0, and this is going to be our mx plus b. Because as long as it's always 1 degree more than, this will always just be an x, and this will always be the constant once we divide, because it's 1 degree more than.
What if it's not?
Then we don't have a slant asymptote. So specifically when we have 1 degree more on top and the bottom. Yep.
Why is essentially like as x approaches positive negative will be mx plus b plus r over d equals mx plus b?
Okay, so when we plug, this is going to approach 0. Because this will be like your divisor, so this will be have a variable of x, and this will be a number. And so that will, remember our limits of infinity would be 0. Okay. Find all asymptotes. Okay. Start with vertical. Huh?
Why do you have plus cross? It's like the first time there's a draw.
I don't know, because it's important. It's pretty though, eh?
Pretty sure you want to roll yet.
Okay, vertical asymptote. How do we find a vertical asymptote? Okay. What makes the denominator 0? So what makes the denominator equal to 0? So plus or minus 3. And what equation does it become? Is it y equals or x equals? So the equation will be x equals, because it's vertical, plus or minus 3. So we have vertical asymptotes at, and we're not sketching it, it's just saying find the asymptote, so we don't have to do our limits here. If I had to sketch it, then I need to find my limits. Okay, so B, horizontal. So how do we check if there's a horizontal? We want to do x approaching infinity. The limit as x approaches infinity. Of our function. So in this case, what's going to happen? We plug in infinity. Will it actually approach some number? It'll approach infinity. Yeah. 3 times infinity. So it's not approaching some number. So what can we say about the horizontal asymptote? No horizontal asymptote. Okay, time for some slant. Slant asymptote. I like that. Is that what you called it? Okay, how do I know I have a slant asymptote? Top degree equals bottom degree plus 1. Check. Okay, so we're going to divide here. I'm going to use long division because it's really quick. I'll show you why it's really quick in synthetic. Just let me show you, okay? You don't actually have to go through all the work. Okay, okay? It's not good. Long division is awesome. Okay. So we start at 3x cubed. What times x squared gives us 3x cubed? 3 and x. Okay, so we get 3x cubed and 3x times negative 9. Negative 27x. I'm going to write that with the x. Okay, now we can go through the rest, but we actually don't need to. And I'm gonna go through the rest with one more step, and then we could be done. We're almost done. So this, we're gonna subtract these. What are we gonna be left with?
Nothing x cubed.
Not nothing. Yeah, nothing x cubed. Yeah.
Negative 8x squared.
Negative 8x minus 0. Negative 8x squared. And then x minus negative 27. So 1 minus the negative 27.
Minus 26. Okay.
Minus. Put a bracket there.
Minus 3.
Okay, so what times x squared gives you negative x squared? No. Oh yeah, I get. You can bring it down. You don't. Yeah, you have to bring it down. You're right. Okay, negative 8. Okay, so we have negative 8x squared and plus 72. So if we subtract this, what are we left with? Now at this point I could stop. Do we have our mx plus b? Yeah, so this is actually going to be our slant asymptote. This is just going to be our remainder that will approach 0, and this will be our slant asymptote, y equals 3x minus 8. So you could actually stop now. Now just for the sake of the theory, I'm just going to keep going. So these are gone. We're left with 28 minus nothing is 28, and negative 3 minus 72 is negative 75. Okay, so our equation, our f of x, we can rewrite it as, so if we divide each one of these by the x squared minus 9, what it becomes is the 3x minus 8 plus our remainder over our divisor. Okay, so this is from this. Okay, let's go back to the basics. Yeah, that was our quotient, right? Plus our remainder over our divisor. So as x approaches infinity, 28x minus 75 over x squared minus 9 will approach 0. Will approach 0 because the degree on top is less than the degree on the bottom. And so our function will approach, so we have a slant asymptote at y equals 3x minus 8. Okay, so when the degree on top is 1 more than the degree on the bottom, as we approach infinity, it's going to take on the characteristics of a line.
So, where you have x equals infinity, that will always happen?
If the degree on top is 1 more than the bottom.
Yeah, on
Yeah.
slant asymptotes, that always happens.
Yep. So this guy here is going to approach 0. So it's cool, right? Like, this example on the first page is really a lot more basic. And we can kind of see how, as we approach infinity, it's going to approach a linear equation. It's going to turn into almost that line. Okay? So we have a couple more things to go through. One more question and just review. When do we have a vertical asymptote? So we have a rational expression. In fact, all three of these happen. We have to have a rational expression. In order to have an asymptote, we're going to have a rational expression. So what's a rational expression? Okay, you have a divisor of x. So for example, x squared plus 3 over x. So ratio, right, means fraction. Expressions are when we use variables, right? Those are expressions. So we have a variable of x on the bottom. Okay, so specifically, when do we have a vertical asymptote? When okay, so variable in denominator Okay, Greg, write this down because you need to know this. And so that's going to be in the form x equals some number. So if we have a variable in the denominator, that's where our vertical asymptote is. Horizontal asymptote, how do we figure out if we have a horizontal asymptote? As x approaches. Right, and so when we do that, as long as our top degree is less than or equal to our bottom degree, we will have a horizontal asymptote. And what form will it be in if it's horizontal? Yeah? Sure.
So if your top degree is bigger than the bottom degree, you won't have horizontal.
Nope. Because what's going to happen, you might have a slant or you might not. Depends if it's one more than. Because you'll have a larger number on top than the bottom. So say we had x cubed over x. As x approaches infinity, it's not going to approach some number.
So then, if it is greater, can you just say there's no, do you have to?
You don't even have to go into it.
Okay. Even on the
Or you could say no horizontal asymptote. Yeah? So you don't, yeah. You have to show me the asymptotes that are there.
Yeah.
That's it. Yeah. Okay, cool beans. And then when do we have slant? Sorry. Groans. Okay, so when the top degree is equal to the bottom plus 1. Oh, sorry, this is going to y equals a number, right? So it'll be y equals 3. And a slant asymptote would look like y equals mx plus b. Are we recording? Yes. Good news. 9 more minutes. Okay, so here's the thing. We have one question, and it incorporates everything.
everything all year?
So my question to you is, do you want to try and work through it yourself and do all parts? And then we'll go over it, or should we do this together?
We should do it now.
Now?
What does now mean?
No, what?
We should do it. Let's try it.
We're going to do the question no matter what. So no matter what, we're going through this. Either you're working through it and then we're going over it, or we're working through it together.
You know how long?
A lot of you don't care?
I think we should do it together. Let's do it because we have the homework we can do by ourselves.
Okay. Okay. So, we're going to go through a domain. We have to include all these parts. Domain.
Well, there's not nearly enough room on this page.
No, but you'll notice. Oh,
You have new.
I didn't give you this guy?
What's that guy?
More room to work? You need a piece of paper. Oh, what's on the next page? Oh, that's Newton's law. Can you use just cross out the next page?
Oh. And what?
No, the examples on the next page.
Oh, on the next page.
Yeah, use that space.
Piece of paper.
No, we did these.
You could probably problem solve this for yourself, right?
We aren't good at problem solving.
Use the back of a quiz.
Back of a quiz, I don't know. Find yourself a piece of paper. Let's go through this. Apparently, these simple tasks are too difficult for you guys.
Real life problem solving skills are so.
Okay, we need symmetry.
Wait, we haven't got paper yet. Ow. I have paper.
You don't have to write this down unless you want to. Can you go quick? Yeah, okay. We're going to do asymptotes. We have to do increase, decrease.
Why are you writing them all down?
Because if you wanted to work ahead, then you know what I need to see. Increase, decrease, max, min points, concavity, and inflection points, and then graph it. Okay, so a little side note, I need to see all that for your assignment number 1. Good, you guys, yeah, there's paper over there, by the way. I need some.
I've done it. Like, honestly,
Yeah, so number 1 on your assignment, you need to do all these steps. I'm telling you now. It's worth 10 marks. In order to get those 10 marks, you gotta do all these. Okay? So you can work on that today.
so I just have to remember A, B, C, D.
I will give you I will give you this, okay? I will give you this on your test.
Parts are worth 2 marks.
Depends.
Yeah.
Asymptotes could, depending on the situation, right? This has 2 parts here. Right here. This has 2 parts, so 2 marks there.
How about they're all just worth 1, but we automatically get a 2?
What?
Worth 10 marks.
You get 2 marks for doing
No. No, you get, usually there's 2, maybe if there's 2 asymptotes and then here, or I'll make the graph worth 2. Okay, let's start a domain. Domain. What's the domain of this graph? So we have to check asymptote. Is there an asymptote? Vertical one. Yeah, where? At 0. So our domain is negative infinity to 0, union 0 to infinity.
I don't know how else to stop anymore.
Sorry. I know, having them at the same time kind of messes you up, hey?
having one at the same time.
Calculus and Math 31.
I know.
Or Math 30.
I don't know how else to write domains anymore.
Okay, B.
You can talk.
Uh,
He's like, I don't know.
do you want to talk to Mr. Trimble? And I don't either. No, it's his call, right? He knows best. You can ask him. Okay, intercepts. Intercepts. So let's start with who?
You eliminate my 25% debt.
No, we don't have to do range. Just domain.
Why is range not a thing?
Because
Because if it's you. So
we'd sketch this puppy, right?
yeah, but if it's got us.
Because it depends. Like you can have an horizontal asymptote, but you can go through the horizontal asymptote.
Why would one do domain first?
Hmm?
I feel like domain should be last.
It's easy.
After you know everything.
Okay, but all you have to check is if there's an asymptote. Otherwise, it's XER. Okay, anyways, moving on. Intercepts. Who do you want to do first? X? Sure. Okay, Y intercepts. Gotta start it somewhere. So we're going to set X to 0. When you set X to 0, we get... So no X and... So none, right? Because you get undefined. Y intercept, or X intercept. Set X or Y equal to 0. When would that be? At 1. So we would write that as X is 1, Y is 0. So that's my X intercept. C. Symmetry. Okay, how do we figure out symmetry? Oh, I hate when I do that. How do you figure it out? Some of you seem to struggle with this guy. If you see if it's odd. Thank you. So we plug in f of negative x, and we want to either turn it into negative f of x or f of x. Okay, if we can create one of those two, we got even or odd. So plugging it in, we have negative x minus 1 cubed all over negative x squared. So here, this is going to be ugly. Okay, we can factor out a negative from all 3 of these guys. So it's going to be a negative on the outside and becomes x plus 1. Because there's 3 of them. So if I factored out a negative from all 3, 3 negatives gives us a positive. Or sorry, a negative on the outside. Okay, all over x squared. Now, is this equal to f of x here? Not even close. So do we have symmetry? No, no symmetry. Yay, no symmetry. Oh, I want to choose different colors. Hold on. No symmetry. Okay, D was asymptotes, finally. Right? Okay, starting at vertical. Will we have a vertical asymptote? Yes, so vertical asymptote at, not just 0, we have to say x equals 0. Okay, vertical line x equals 0. What do we have to include with this puppy? Limits. So we need 0 from the left, 0 from the right. I was going to make a song, I didn't know how to rhyme. Okay, so plugging in our function. Actually, I'm going to probably just go like this. Let's write in our actual function, which was x minus 1 cubed over x. So if I plug in 0 from the left, negative 0.000001, we're going to have a negative over a small, well, we're squaring it. So it doesn't matter. It's going to always come out as a small positive. So this guy, negative over small positive, negative of infinity. How about this guy? If we plug in, it's still going to be, if we put in 0 from the right, you're going to have a negative over a small positive squared, still going to be negative infinity. Okay, finally we can get into the rest of the stuff. Awesome, now we have to derive this guy. Oh yeah, thanks. I don't know what I was thinking. Horizontal, will we have horizontal? Top has to be less than or equal to the bottom. Is that the case? No, so no horizontal. However, will we have a slant? Yes. Okay, slant asymptote. So we need to figure this guy out.
How do we know it's horizontal?
Because top has to be less than or equal to bottom.
Oh. So you can't have a slant at the...
Right, you can only have 2. Right.
You can have a slant. Oh, vertical.
Yeah.
And a vertical. So a vertical is just the middle that people want.
Yeah, exactly. Okay. So we need to long divide. We have our dividing. Oh, we have to expand our function, don't we? Yep. Okay, we have to cube x minus 1. Okay. Did you learn a shortcut?
Yeah.
Okay.
Yeah, we learned Pascal's triangle.
Hey. Yeah. Okay, so y equals that. So we need to expand this. So do you want to just do it the old-fashioned way? X squared minus 2x plus 1 times x minus 1. This is an x squared, right? And then last would be x cubed. We'll have a minus x squared and a minus 2x squared gives you minus 3x squared. And then we have a plus 2 and a plus 1, so plus 3x. And last would be minus 1 all over x squared. Hope you have extra paper. Okay, finally we can long divide. What times x squared gives you x cubed? X. Okay, so x cubed. Well, that's it. Subtract is 0. Bring down the minus 3x squared plus 3x minus 1. What times x squared gives you minus 3x squared? Negative 3. Do you actually have to continue anymore? No, so we know we have a slant asymptote at, because we have our mx plus b now. We don't have to figure out the remainder, which will approach a 0. What?
Why can't there's x to the 4 into the bracket? And it would be a
Except then you would have x.
And if this was an x, it would be an x to the 3 on the outside. Yeah. So because the degree on the bottom is 1 less than the top, it'll always work out to be a linear up here.
Why can't 3x squared be divided by x squared?
We did negative 3 times x gave us negative 3x squared. I never continued. Right? Once we have this, we can stop, because this is our mx plus b. Okay, so we go, what times x will give you x cubed? Or what times, so we figured this out, because we know we need to make this to cancel out. So something times x squared has to give us x cubed. That something has to be x. X times x squared. So then we subtract these. And I bring down the rest of them. So this was gone. So then we brought this down. Now this wasn't here. And I asked myself, I want to get rid of this guy. What times x squared gives me negative 3x squared? Negative 3. Negative 3 times this would give you the negative 3x squared. We subtract, and this would be my remainder. Okay, but it's going to approach 0, so all we need is this guy once we get here. I'll see if I can figure out a way to show you after with that. Okay. So slant asymptote at y equals x minus 3. Okay, what's next? Increase, decrease? Unfortunately, we have to derive this guy. X squared. Do you want me to just give you the derivative? Okay, that was easy. Oops, this is the original function. Okay, so your derivative is going to be this. You have to work it out. X minus 1 squared, couldn't read my own writing, times x plus 2 all over x cubed. Okay? Where do we go from here? If we did all that work to derive this. Critical values. So what are our critical values? 2, 0, and 1. Negative 2, thank you. So negative 2, 0, 1. When we test our intervals, where am I plugging these into? The first derivative, yeah. Because this actually is f prime of x. So these are my x values, and I want to see, are the y values going to be positive, or are the y values going to be negative? Negative 3. Okay. I find, right, the smaller the number, the easier it is. Yeah, because then negative 3 minus...
No, as in negative 10 being smaller than negative 3.
Oh, sure, negative 10. So this will be negative 10 minus 1 squared, positive, or negative squared, which is positive. Negative 10 plus 2 would be negative all over negative 10 cubed, which would be negative. So this guy, Vincent, can you put that on my desk? I'm sorry, but you need to be here with us. Put it on my desk. Come on. Thanks, buddy. Okay. Now you're going to have to do negative 1. Be the best. Negative 1 minus 1 would be negative squared positive. Okay? That's guy always going to be positive, right? The first guy is always positive. Negative 1 minus, or plus 2. Positive. Negative 1 cubed. Negative. Use negative. Okay, first one done. 0.5 plus 2. Positive. And positive. And last, this guy's always positive. 2 plus 2, positive, positive cubed, positive. Okay. Now, what could be helpful is, did we figure out any vertical asymptotes?
Well, clearly there's one there.
Where was the vertical asymptote? 0? Okay, it's nice to put that in because then you know right off the bat you're not going to be testing it as a max or a min value. Right? It's not possible. So let's state our increase, decrease. So we're increasing when? Wiley, can you throw that on my desk, please? Thanks. Negative infinity to negative 2, 0, oops, forgot the U. Now, what could I say 0 to infinity? No, because that's a 0 here, not a positive or a negative. So we have to actually separate all of this. That's why having our critical value test is so helpful too. And then decreasing, negative 2 to 0. Because this is neither positive nor negative, it's 0.
How do we know?
Because it's a critical value.
So the
Slope is 0. Well, we're going to draw it, but we know it probably will be an inflection point. Yeah, yeah, because then in order for, yeah, exactly. It has to be an inflection point. Sorry. Okay. Okay, F. We need to do our max mins. Do we have any max mins? So we increase, decrease, increase, increase. So max at negative 2. And you already plugged it in? Negative 2 and what? Thank you. On your written response in your exam, I'll just take decimals. Don't have to be. There are scientific calculators that do fractions. Yeah, some of those ones do.
Everything this except graph.
Yep, those ones do, I think, pretty much. Oh, no, I don't know. I don't know about that. Okay. G, do you want me to give you your second derivative? Save some time. Or do you want to derive that baby? It's really ugly. It's really ugly. Like, it took up all this space. Okay, so our second derivative, once you work it out, it's really pretty. Took me a while to get there. Okay, there's our second derivative. When you have that guy, I would have used the expanded form to derive. Or wait, is that what I did? No, I did product law. So you did any quotient, and then on the top was, when you derive the top, you do product law. So it turns out to be x cubed times, yeah, the product law of that, minus 3x squared, keep that all over the bottom squared. It's pretty ugly. Yeah. Probably not this ugly. No, you have to derive it.
So if we mess up like the first derivative, what will you do?
Don't mess it up. I might not make it really ugly, so you.
So what if we do?
Well, you're gonna lose some marks.
What if we get like 1 out of 9?
You're gonna get pretty little. Okay, can you guys finish this part off and then try and sketch it? We'll go over that. Thank you. Okay, so there's the rest of that. We need to include 0, 1 in our sketch, negative 2, and we need to be able to sketch y equals x minus 3. Okay. Here's the thing. I'm guessing you guys should try and sketch this on your own, because this is where students often struggle.
Wait. On the test, are we gonna have like A grid like
I'll give you a grid.
Okay, good.
Okay? So, yeah. We know your critical points, right? We need to include those. We also need to include our asymptotes. And one of them is an equation of a line. So, I'll give you a grid. I'm going to show you a little, I don't know if this is helpful or not, but I can try and be helpful. That's not nice. Okay. So zeros, where were our intercepts? Where were our intercepts? We had one at 1 and 0, right? That's the only one. X equals 1 and y is 0. There's no y-intercept. We also need to include our asymptotes. So one of the asymptotes is 0. Okay, that's one of them. What's the other one? X plus 3. So the y-intercept is 3. Is it minus 3? Thank you. So here would be the y-intercept of that asymptote. And so it's going to go through, and it's a positive slope, so it's going to go through 3 here. Yeah, this is an asymptote, right? So this is the asymptote, the slant asymptote, y equals x minus 3. Yep. There is no, yeah, it's a vertical asymptote. Yeah. This is just the y-intercept of this graph, this line. I was trying to graph that line. Okay, there's critical points. One of the critical points is 1, right? 1 and 0. What was that? An inflection point. Okay, there's an inflection point here. We had a min, didn't we? Or is it a max? Let's look. Max, -2, and -6.75. 1, 2, 3, 4, 5, 6, 7.5, right there. And this is a max. Okay, I need my graph to go lower. Okay, well, okay, so I don't know what to say. Okay, a point, -2, -6.75. Okay, symmetry, no symmetry, asymptotes, we got those covered. We got our verse. Now we can, okay, where are we increasing and where are we decreasing? So this is where I like to lightly in pencil go like this. Pencil, calligraphy. Ooh, crayon. Let's do crayon. No, crayons are ugly. There you go. Okay, so lightly what I'll do is we're increasing. So we have that interval line test. So the one I'm talking about is here. So we're increasing, decreasing, increasing, increasing. So we want to include those. So up to -2, we're increasing. So here's my -2, and so I'm increasing up to -2. Then we decrease to 0. Can you see that a little bit faintly? And then we're increasing the rest of the time, right? Increase, 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 increase. Okay? And then below I'm going to show my concave up and down. So we were concave down to 0. So all of this should be concave down. And then we're concave down again all the way to actually 1. There's my inflection point, and forever on will be concave up. Okay? So I'm going to use it as a guide when I'm sketching. So we're going to sketch in yellow. Okay. let's start over here. We want to be increasing up until our max, and then we're decreasing, and the whole time we're concave down. We also have to keep in mind that we're approaching our asymptotes. We already figured out that with my vertical asymptote, we did the limits, right? We're always going to approach on both sides negative infinity. So this will be negative infinity, and this will be negative infinity here because of our asymptotes. Okay, we need to get up to our inflection point. So here, we're increasing and we're concave down. Are we allowed to cross our slant asymptote? Yes. Vertical asymptotes, no, but slant and horizontal, yes. Why? Because they only tell us what we approach as we go towards infinity. Okay, so we're going to go up to our inflection point. We're concave down, and now I'm going to switch. I'm still increasing, and I want us to be concave down. So we're going to go become up. Thank you. So now this is inflection point. It's really ugly. Sorry. Well, you know, if you're going to criticize me. And there we go. Okay, so here we're increasing. We're concave up. We're approaching our asymptote. And there's our graph. Pretty ugly, hey? Okay. So the idea of a slant asymptote, right, is as we approach infinity, we're approaching that line. Okay? All right, so your assignments, I'd love to see them on Monday. I prefer, please get them in on Monday. They're due Monday.
Wait.
Monday. Monday. No, it's due Monday. Okay?